Good morning, good afternoon to our audience. It's an absolute pleasure to introduce with me today Greg, founder of Penguin Automated Systems. Greg, it's a pleasure to have you here with us. Please, if you could do a quick introduction and tell us what it is that you guys do.
Well, I'm a PhD mining engineer. Used to work for a large mining company called Inco, which is now Vale. Um, one of my job was to be the global head of R&D for the organization and work on new techniques for mining that would improve safety and lower costs to ensure the long-term viability of the operations here. One of the key areas that we focused on was how to apply robotics to mining. And so when I left Inco, I was awarded a Canadian Research Chair at the university and started a company called Penguin Automated Systems, which focused on new mining techniques using robots.
Super cool. And it makes me, but before we dive into how the robotics work or what they do, it makes me curious. You were head of research and development at Inco. Just curious about your journey. How did you get into the mining industry, and was there a passion behind it?
How I got into mining was that I was taking civil engineering and playing hockey, and at a place called Ryerson, and the mining engineering school was recruiting uh, students to come down, and Queens, where I went to university, had a great hockey team, and so they wanted me to play on the hockey team, and I kind of stumbled into the mining industry.
Yeah, there's
That's how
definitely a
I
lot of
got in it.
influence. Yeah, there's definitely a lot of
Yeah.
influence, especially in Canada. As we know, we're Peruvian, so here in Peru, like the mining industry and the university is huge. You walk down the street, down the downtown, like you'll come across a couple of mining executives or a couple of mining companies. In the hockey, in the university, that's how you got into that. So, could you tell me a little bit about the priority of your robots? What is it exactly that they're solving, or what it is that they do?
Well, mostly the majority of the problems that the current mining industry wants to get solved have to do with safety. We've worked on several different kinds of robotic systems. One was how do you go in and map a mine that is currently abandoned and get that information back out. In one particular case, the mine had a problem. They had to have a zero entry protocol because there was the potential for a large explosion inside the mine after it had been abandoned for a couple of years. So we built a robot system that went and traveled down the ramp into the mine to try and get a scan of the inside of a stope on the crown pillar so that we could see how stable the ground was up above so they could go in and remove an explosive device that was sitting up on top. From there, it kind of evolved into doing some work with NASA around space mining, doing some work on undersea mining, because all those are zero entry kinds of operations. And so it's kind of evolved from the safety side through to looking at the more difficult problems in mining.
Mentioning these projects, I mean, they sound incredibly dangerous if a human would have to go in and map, anything up subterranean, going down and dismantling primers or detonators. Of course, it would make sense to not risk human lives, even though like we see it happening on a day-to-day basis, always in the mining industry. Explosive dismantling, you designed a specific solution. How complex of explosives are they trained or programmed to dismantle?
In the case where we were dismantling explosives, it was an open pit explosives column. So how you put those in is basically a drill goes and drills its hole to its appropriate depth. Then they come and load it by hand with primer and detonator hanging in the bottom of the hole, and then put either slurry or ammonium nitrate on top. And so now you have to do the opposite process.
Yeah.
So it's having a robot that has accurate enough positioning that it can discern where the hole is. Then instead of drilling a hole, you have to auger the hole out so that you can go down and auger the explosives out of the way and bring them to surface. Then you had to be able to go in and take the remaining explosive because you didn't want to drill into the primer and the detonator. And so you had to get within a few inches of where the primer and detonator were, and then liquefy the explosives and use cameras to grab onto the primer and detonator and bring it up to surface and lay it on the ground. That work needed to be done in this particular case 600 times because there were 600 holes to dismantle the pattern. And so we took thermal imaging cameras on robots and went and identified what the temperature of the holes were at the collars, and came up and did a complete map of the 600 holes so we knew where the hottest spots were. It was necessary to restore the mine. Um, if you think about it, it's a bit like what happened in, I think it was Iraq, when in the war they went and blew off all the oil wells and they were all on fire, and the Red Adair had to go in and uh, half them all.
Exploded, right?
Yeah, yeah, you had to
That
explode it to shut it off, each one of
yeah.
them. And we had to do almost exactly the same thing but dismantle the holes. In the end, we never really got to put the final robots into play because the mining company ended up abandoning the mine.
These technologies that were created and these abilities have opened up the path so much, and it sounds like an astounding piece of tech, and I'm sure that's why they have the robotics like also in space doing the projects.
Original formulation of Pathfinder mission to Mars. The people, some people from NASA had heard that I was running three production drills from a surface control room 25 kilometers away from the actual command center.
Oh yeah.
And so their mandate was if they were going to send a drill to Mars, that they needed to see that this was a possibility on Earth already. What I find so interesting about that is just in the last couple of months, they actually are saying that they've found some fossilized um, portions in the rock that was on Mars, which is the first indication of life on another planetary body. And so, it's an honor. And I wrote the article more because of all the people that I worked with who created the systems to allow that to occur. The mining industry, my R&D group and the people that worked in it were involved in the initial steps of finding life on another planet.
Great accomplishment for your team, for the industry, and for humanity. We weren't like looking for life on Mars. Like, was there an initial purpose for the drill that they were drilling on Mars?
NASA, I believe, and I can't speak for NASA, but I believe NASA is always looking for indications of geology and potential for life. And I was at what was called the Desert Rats program that NASA put on. And in that program, what occurred was I was brought in to be the mining engineer in the equivalent of mission control for a simulated Mars mission in Flagstaff, Arizona. And so I went with, and it was a wonderful experience because all the guys who were in the original Apollo moon landing mission control were there, and I was kind of the young guy. And so I got to hear all the war stories of when Neil Armstrong and all these guys went out to collect rock samples on the moon, because it was basically a geologic mission to go to the moon. And then I was in this simulated control room for doing the same thing on Mars. And I was there because of they wanted me to look at some of the rovers that they were talking about putting on, the manned rovers they were talking about putting on Mars, for geologists to go and look at the geology and sample it. What's the movie? I think
It
it's Matt
sounds
Damon.
kind of
Matt
fun.
Damon. Yeah,
Oh,
Matt Damon. I think it was he
The Martian,
was
you know?
the Martian, and the unit that they showed him in, that was the mineralogical lab that they used at NASA. So they loaned it to the movie to be able to see it. And so I've actually been in the lab, and when I go to the movie now, or I see it, I know what it was actually built for in the first place.
That's incredible. So it's not like a prop, you know, it's like the actual
No, it's
like
a
real
real
life
thing.
set. That's probably why it's really important to send robots up there because if there's some like catastrophic storm, you know, and like they have to abandon ship, and then Matt Damon gets left on Mars for like a couple years just alone. Like probably a bit better if a robot just gets left up there, you know, instead of a human life.
Yeah, it's fascinating because that problem is just happening right now. I've actually been talking with one of my colleagues, and he was the medical director for NASA. And right now, they've got an astronaut with a medical emergency that they have to bring back from the space station. And
Oh my
so
God.
he and I have been talking about when you have such a failure, right? Because somebody getting that sick, it's one thing to be in orbit. It's another thing if you're a year away from coming home.
Yeah. Oh yeah.
And so I said, like, what are the robotic learnings that we can get out of this? Because I said they've diagnosed the problem with an onboard ultrasonic scanner. So they know what the problem is with the guy. I don't know the actual diagnosis, but they've diagnosed him, but now they've determined that they can't do anything about it in orbit. And so that's why they have to bring him home. And I was
Mhm.
asking Jim, I said, what robot systems do we need for medical robotics to ensure that this doesn't have to occur? Because if you're on the moon or you're on Mars or you're somewhere else, it can't occur. Star Trek had a sick bay and there's a way to look after people. And so how are you going to do
Teleport them
that?
too. And you can teleport them
Yeah.
too. Explosive capabilities, about how like they're measuring the temperature and like precise actions. And now we're even speaking about potential medical assistance in off-planet operations, you know. So I'm kind of curious about like the endeavors. Where are we in development, and are there any actual new testing or new abilities that maybe you could even speak about on a high level?
It was kind of funny. I built the robot for them a long time ago, but it kind of showed up at the mine site and it was almost a bit shocking to them. And they wanted to go in and with a robot reach up 30 feet, determine where the keystone was, and then drill a hole and load explosive to remove the keystone so the blockage would come down. You can imagine that having an arm that goes up 30 feet requires quite a counterweight. So the robot itself is quite big in terms of weight, so it can hold the robot arm. When it showed up at site, I think they were expecting like a Rumba to clean the floor. And, and it ended up being like a 6-ton machine with a
Yeah.
robot arm on it. And so now what's kind of fascinating is that they didn't understand the complications in terms of safety and explosives and how you have to work together and how the robots have to be able to supply it up there. And you don't want to send the robot in to do just one shot. You want to send it in to do a dozen shots. So you're working in there and having explosives that are prime ready to go on a mobile machine is like a no-no in the safety regulations. So I had to do some pretty fancy things with explosives to develop specialty charges that could go in and drill the hole and then be loaded. When we originally did the robot, that was the logic behind why build a robot. You've got to take the people out of being exposed. And so now here we are, where these super caves are becoming a big deal, and you've got to get the exposure level down for the workers. What I mean by super caves is that they were working at the mine where the project started. It was a 60,000 ton a day mine, and they were looking at how they brought it up to a
Amazing.
250,000 ton a day mine. And it just
Amazing.
meant the number of exposures was going to go up to be able to do this. And so they had to mitigate the risk of people being hurt.
Normal, like you can look at like a small scale mine. I mean, you'd be lucky to get like 5 to 20,000 tons, like, a month out,
Yes.
These are like incredibly large mines. So
Yes.
we're developing new technology for them. People stay out of high risk environments. What is it that we're looking for in like terms of business growth? Are there any challenges at all? And how are you overcoming in this next year?
The biggest issue with growth and robotics in the mining industry today is culture. People becoming accepting of robots working side by side with them. And it's
Adoption.
still the same problem. Yeah, adoption. Still the same problem in manufacturing to a lesser extent. I remember going to a meeting and a guy said it used to be that we would have to go into meetings in the automobile industry and we would have to justify putting in robotics. And he said the script flipped and he said now people have to justify putting in manual operation. And that's going to happen in mining eventually as well.
Especially in some of these small scale mines or artisanal mines. I mean, the the workers, like, they go down there because they need to feed their family, right? And that's just a whole like paradox because we want to improve health and safety. We want to save lives and we want to make sure everything is safe and that robots get hurt and not humans. However,
Right.
that's a bit of a paradox how they need to like feed their family and like their grandchildren with like just nuggets of gold and silver and sell it. So that is a
That's the
challenge.
paradox. That's the
Yeah,
paradox,
that
right?
is
And
definitely a
and
challenge.
a lot of the current mining operations are very what I would call a lot of brawn and people that are big and strong and all those things. Well, those jobs are going to change to being more intellectual jobs and knowledge-based jobs. When I was running the drills from surface, um, I wanted to bring a dignitary to see the drills operating. And the operator was a woman by the name of Lori Jewell. And Lori was in the center running 3 drills from one command center, the thing that NASA came to see. So I got there and it was a snowy night in January, and I'm bringing this dignitary in at like 10:30 at night, and here's Lori outside, starting her car and brushing the snow off, and I'm going, oh no, like nothing's working inside. I've just brought this dignitary to see this amazing setup we have, and everything's down. And I went over to see Lori and she said, no, 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 it's all fine. She said, usually what I do before I leave is she said, I put drill rods in every one of the drills and then it's coordinated, and know I have 10 minutes before I have to be back in there. So I come out and start up my car and dust it off. And she said, go inside, you'll see everything working by itself. And she said, my next step is that when I get ready to go home, I load another rod in, and the drills keep drilling while I'm not there, and for another 30 minutes. And so, it's a totally different mindset where before Lori was doing that, it would be, we got to go to the dry, we got to get changed, we got to go down in the shaft, we got to walk out on the level, and then you work. And when it's time to go home, well, you have that procedure on the way out. So you start preparing to go home 2 hours before it's time to go home, where Lori's preparing while the drills are working. So it's a totally different mindset in how it works.
Like when we're talking about like machine learning capabilities or deep learning or artificial intelligence, like we've been using this for a really long time. It's not like a new technology for us. So I guess my question is, how is artificial intelligence being used in Penguin ASI or your robotics? How long has it been used for, and what are the best priorities of usage in your workflows or operations that you're seeing?
A lot of the
Stack.
people you see in that are considered thought leaders in Google, I've funded their research work through the mining industry.
Yeah, exactly.
Um, and so there
Mars
are,
rovers and space exploration.
yeah,
Like, yeah, it started there.
there are many applications of artificial intelligence to the mining industry. Some of the basics are in robot system control. When we were running cooperative robots, you hear a lot of talk about swarming. You
Oh,
see some of the drone equivalent of fireworks displays. Those are all coordinated drones swarming together. Well, we've been working in that field in Penguin for 25 years and are quite good at it. And those are going to be applied in everything from geology, to look at the rock, and determine what parameters need to go into databases, to how we're going to coordinate robots for doing various tasks. Like, most people in the mining industry think of tunneling, right? And tunneling is a jumbo. Then a guy goes in with explosives. Another person goes in with a mucking machine or a scoop trim. Another person goes in and does ground support. I look at all those and I go, oh, that's coordinating four different kinds of robots having to work together, which is how you manage a swarm. And
yeah.
so you're going to see the same thing in production systems and in coordination of supplies and all kinds of stuff that are going to be, um, have artificial intelligence applications. And they'll streamline the process. They'll ensure, you know, we don't get too many supplies around, and manage timing and all kinds of stuff. So it's going to be, um, quite an application space for in mining, for artificial intelligence as we go into the future.
Yeah, it's a great use. And we hear different responses and coordination, basically the choreographed motions being precise with your equipment. Great use of artificial intelligence that must generate a lot. And I promise you this is the last one because that must generate a lot of data. I mean, how do you guys do data analysis or data science, or is there like a ecosystem or cloud environment that like is able to analyze all of this data from your incoming equipment?
Yeah, we have the analysis tools to do that kind of work.
Yeah.
Um, and it's a huge amount of data, and you've got to sift through it as it comes in, determine where the good points and the bad points are, and then react to them. And so,
Hmm.
that at the end of the day, that's really what artificial intelligence is good at. You want to it can artificial intelligence and the data streams can react at a um, several orders of magnitude faster than a human being can. And so, there are things we do in mining that are going to use that kind of technology. I just look at some of the basics about how you coordinate explosive charges and how you drill and all those things are going to have applications for artificial intelligence.
If anyone would like to get into contact with yourself or with your team or get to know a little bit more about your robotics, what's the best way to get in touch or to learn more about it?
There's two ways. One is to go into LinkedIn and type in my name. It's Greg Baiden, Baiden, or people can email me at gbaden@penguinasi.com. Right at the moment, I've taken my website down more because we're revamping it. But we're going to put it back up probably in I'd say the next month or so. But the best way is through my email or through LinkedIn right now.
That's incredible. Yeah, of course, we'll leave the link of your email, your LinkedIn down below. Thank you so much, Greg, for coming on the show. Thank you all to our audience for listening. Greg, it's been a pleasure, and thank you all for being here. Thank you so much, Greg.
Thanks for having me.